Till now, we have understood multi-tier architecture of a IoT ecosystem. Now let's take it one level forward. We will go little deeper and we will understand multi-level processing which happens in IoT ecosystem. We will try to understand this with a use case, and in this use case, we will take a example of a smart hospital. So let's assume that there is a hospital. This hospital has got 4 floors, and every floor has got some department. Floor 1 is gynecology, floor 2 is orthopedics, floor 3 is something, and floor 4 is something. And this is about 200 bed hospital. On every floor we have 50 beds, and every bed had something called bedside monitor along with the bed. Here on first floor you will have multiple beds, second floor you have beds, third floor you have beds. We will assume that every floor has got 50 beds, and this is a 200 bed hospital, which means there would be approximately 200 bedside monitors. So what is a bedside monitor? Bedside monitor is an equipment which is attached to every bed in the hospital, and this has multiple sensors which will be attached to patient's body, and this monitor will keep measuring different parameters of patient like blood pressure, oxygen level, heart rate, etc., etc. So whatever medical parameters are there, this bedside monitor will keep detecting those parameters, and at a certain frequency, let's say every 30 seconds or maybe every minute, it will keep sensing those parameters and it will keep sending it to the backend server. Now this bedside monitor keep capturing the data and it keeps sending the data to the backend system, right? The backend system is there on a cloud. You will assume that this is there on the cloud. There is a data center where all the data will be pushed and all this data will be processed from there. And then behind the scene, you may also have multiple applications which may be used for various purposes like monitoring. This is clear. We have a hospital, 200 bed hospital. All this 200 bed has got bedside monitor, and these monitors are constantly capturing data and sending to the backend system. And this hospital has more branches in the city. So we will assume it has 4 more branches. This is a hospital in Delhi and it has 4 branches. All the branches are 200 bed. So 200 bed here, 200 bed in this one, second hospital, 200 bed in the third hospital, and 200 bed in the fourth hospital. And this is just in Delhi. This hospital also have branches in other cities, and we will talk about it. And then this bedside monitor may not all be same. So the bedside monitor in a gynecology department may be very different from bedside monitor in orthopedic department. The bedside monitor where you have pregnant mothers, that monitor may be capturing the heart rate of the baby which is in mother's womb, and that kind of requirement may not be there in orthopedics. So the bedside monitor may be different in different departments, because in different departments the kind of parameter which you want to capture from patient may be different. So all these 4 hospitals in one city, this is only in one city, all these 4 hospitals are capturing data, and this data is being sent to the backend system. Now what will be problem with this kind of system? The backend system may get congested because of so much of data getting pushed from all these bedside monitor in all the hospital. Each bedside monitor is capturing data at the frequency of 1 minute, and so many bedside monitors are constantly pushing the data to the backend system. So there will be too much of data. Is there a way to reduce this data? Is there a way to optimize this system? What we will do is we will put one edge server in every hospital. So instead of all the data being sent to the backend server, single data center, we will have edge server for every hospital. Every hospital will have its own edge server, and all these monitors will send data only to the edge server. They will not send to the backend system, to the respective edge server. So all the monitor in this hospital will keep sending data to the respective edge server, and edge, in the edge, it will do some amount of pre-processing, it can do certain amount of consolidation, and then it will send data to the backend system. All right. All the data need not be sent to the central data center as it is. We can do certain level of pre-processing, certain level of filtering, certain level of consolidation at the edge, and then the consolidated, filtered and pre-processed data will be sent to the cloud. So by this, you can reduce the load on cloud server. You can reduce the load on cloud server by doing a certain amount of processing at the edge location. The second advantage will be because edge is in a closer proximity to all the devices, the communication will be faster. The device do not have to go to the cloud every time because cloud server may be somewhere in a different city or maybe different country also, right? So the edge server is there in the hospital itself in a closer proximity to all the devices, and therefore all the devices can do a faster communication with the edge server. Can this be optimized further? Yes. Now along with edge server, what we will do is we will put one gateway on every floor. Every floor has got 50 bedside monitors. So we will put one gateway on every floor. So all these bedside monitor will now talk to gateway, and then this gateway will talk to edge, and then edge will do consolidation and some pre-processing, and then we'll send the data to the backend server, right? And why are we doing that? To optimize the system. Just like if you have to manage a large country, so India is a big country, and in India we have multiple states. Within states we have districts. Why is it being done? To do a better administration. Everything cannot go to center, right? Everything cannot go to center. Similarly here, when you have so much of data, you have large volume of data, everything if you try to push to the central data center, then there can be latency issue, there can be performance issue, the central data center can get overloaded. In order to optimize that, we can put multiple layers of processing. So one such thing is edge, second such thing is gateway, and then we can have a regional data center because this hospital also has branches in other cities. So in Delhi it has 4 branches. In Delhi we will have one regional data center. In Mumbai it may have more branches. For Mumbai we will have one data center. Maybe in Chennai it has more branches. So for Chennai we can have more data center. So this is called fog computing. So in this example, we have seen multiple layers of computing. There may be some amount of computing which may be happening in the bedside monitor itself. Bedside monitor may also have some small processor, and it may be doing certain level of processing. For example, whenever there is a abnormality observed in the patient, there will be some kind of error which will be thrown only on that particular bedside monitor. There are hundreds of bedside monitor, and each monitor is attached to one patient. But if there is a problem at one patient, that particular monitor will reflect the anomaly on its screen. Apart from devices, you can have certain level of processing being done at the gateway. What kind of processing can be done on gateway? Typically some kind of consolidation, some kind of data filtering. What kind of processing can be done on edge? Depends upon what kind of servers are we putting on edge. We can have a powerful server which can also do AI ML analytics. So depending upon what kind of computing power we put on every device or every gateway or edge, so the computing will depend upon that. Obviously it will increase the cost of the device, but it all depends upon setup. There is no standard as such. It all depends upon case to case. So in edge server, certain amount of processing can be done, and then we have this regional data center which is called fog, and then eventually we have cloud. So cloud server would be the central data centers. Then we have fog server which is regional data center. Then we have edge which is in closer proximity to user, and then we have gateway. Gateway is also called mist. It can also be called extreme edge. It can also be called extreme edge. It is in very close proximity of the user. So this is the concept of cloud, fog, edge, mist and device computing. So cloud is the central data center, fog is the regional data center, edge is in closer proximity to user, probably in the same building. Then we have gateway, mist computing, which is very close to devices, and some computing can happen in device itself. Mist computing is also called extreme edge. So this is how multi-layer processing is being done. Why this is being done? What is need of multi-layer processing? Because there could be huge, enormous amount of data which could be produced by all this sensor. When you have hundreds, thousands and millions of devices, these devices may be producing so much of data, and it may not be practically good idea to send all the data to one central location. Therefore, we have to have a hierarchical structure. So to handle huge amount of data, to bring in more efficiency in the system, to give better experience to the user by reducing the latency. This is the idea behind multi-layer processing. So in multi-layer processing, you can do data filtering, you can do data cleanup and transformation at different layers. Certain cleanup, certain filtering, certain consolidation can be done at mixed computing level, certain thing can be done at edge computing level. There is no clear standard. There is no standard for this. It all depends upon the implementation and how the enterprise architects, solution architects have designed the system. So different system may have altogether different kind of implementations. It all depends upon case. In IoT, one of the key expectation is real-time responses. In IoT, one of the key expectation is real-time responses. Whether you have a smart traffic management, whether you have a smart building management, you always expect real-time responses. If there is a fire in the building, you may want to know it in real time and you want to respond back in the real time. Similarly, if there is some kind of accident which has happened on the road, you want to know it in real time and you may want to respond in the real time. So to get real time responses, it's very important that the communication and processing and the command back from the command center happens quickly, and therefore this multi-layer processing helps in bringing in that efficiency in the system. IoT is quite a diverse, it's a heterogeneous ecosystem. There are multiple components, there is lack of standardization, and that brings in big challenge in designing and implementing a efficient IoT system. All right, so I hope multi-layer processing is clarified. Now we are going to talk about the key components when it comes to cloud integration. We have been talking about cloud. So when it comes to cloud integrations, what are the key components? What are those components in cloud which we will leverage in a IoT ecosystem? When we say cloud, cloud can be a public cloud, it can be a private cloud, it can be a hybrid cloud. In public cloud, the biggest name in the market are AWS, then we have Microsoft Azure and Google Cloud, GCP. Private cloud would be set up by the respective companies. It's very much private to the company. The advantage with public cloud is that it has got many platform as a services and software as a services thing which we can very easily integrate with your IoT ecosystem. We will just talk about some of the components which are available in AWS which can help to manage the enormous amount of data and which can help us to integrate the devices directly with the backend system.